Number 17, integral from 0 to pi t times cosine squared t dt. Okay, if you've done enough practice, you probably remember that t cosine t dt is integration by parts. But this is cosine squared t. So does that make a difference? Can we use a different strategy? Well, if you remember, integration by parts is useful when it's a product of two things. This is kind of product of two random things, so maybe we should use integration by parts. We can't do a u sub. I don't see what we would get out of that. Not a typical trig integral with those strategies that you learned for sine and cosine, powers of sine and cosine. I don't want to do tricks over here for sure. It's going to make it way more complicated. It's not a rational function, so no partial fraction decomposition. Okay, so let's try integration by parts. So we need to choose our u and our dv. Let's choose u to be t because the guideline is we want to choose u to be something that differentiates to something simpler, unless we don't know the integral of the second term, but we do. Okay, what's dv? That is cosine squared t dt. What is v then? This we have to remember the half angle identity. So it's the integral of half 1 plus cosine 2 theta d theta. So v is equal to half times theta plus half sine 2 theta. Okay, I don't know why I use theta. It's t. Let me change those to a t real quick. I probably remember the half angle identity with theta. That's probably why. Okay, so now the steps are the same though. uv minus v du. So uv is half t squared plus t over 2 sine of 2t. We want to evaluate this from 0 to pi. And then minus integral of, let's pull the half out in front, t plus half sine 2t dt from 0 to pi. Okay, now I evaluate everything at the end typically. So let me even distribute that half t squared plus t over 4 sine of 2t minus half t squared over 2 plus will be minus then over here because there'll be that minus a fourth sine 2t plus c. Not sine, the integral sine is cosine. Okay, that's why you should double check when you're not certain. Okay, and when there's lots of things going on. Okay, I think we're in good shape now. So not plus c, sorry, there's a definite integral as well. Evaluate from 0 to pi. Okay, so we get half pi squared. Sine of 2 pi 0, so that term will go away. And then minus a fourth pi squared. Okay, and then the cosine of 2 pi is 1, so we get plus 1/8 there. And then let's plug in the lower bound now. The first two terms will go away. The third term will also go away, and then we get minus 1/8. So these two would cancel, and we are left with a fourth pi squared. Here's our answer. Let me double check. Oh yeah, good. Okay. See, so hopefully you can see when you're very uncertain if you integrate it correctly, double check right away so that the errors don't propagate at the end. Okay? You should be double checking every few lines of work.